Alright, for our next problem and final problem from chapter 4, we're going to list the asymptotes, intercepts, and holes of this function, and maybe even sketch it. The tricky part here is in factoring both the top and the bottom to get the following. And I'm saving some time and effort in giving you this, but bottom line is plug these in and use rational root theorem. Rational root theorem in this situation is going to be relatively simple. There are only so many roots of negative 8. 1, negative 1, 2, negative 2, 4, negative 4, and 8, negative 8. The ones that work are negative 2, which gives us an x minus 2, or actually x plus 2, excuse me. X plus 1, because negative 1 is a root, and 4 is a root, so x minus 4. All of this over the factorization of this polynomial. So when we factor this one, we're going to get x minus 1, x plus 2, and x plus 3. Alright. Now, with that done, we can observe that there's some cancellation that happens. And when cancellation happens, you have a hole. So the hole is going to be at x equals negative 2. Because when negative 2 is plugged in, you're going to have 0 over 0. So it's undefined, and we'll figure out the y-coordinate of the hole is momentarily. But I'm going to say that f of x is approximately equal to x plus 1, x minus 4, over x minus 1, x plus 3. And it's in here that we have all the other information that we're asked for. So, when we need to find the asymptotes, so the horizontal asymptote, that we can figure out before even factoring. What happens as x gets really large? Well, these are both the same degree, so it's going to be a 1 over 1. So the horizontal asymptote is y equals 1. The vertical asymptotes, well, those are where the denominator is undefined. It's where we divide by 0. So it's the roots associated with these factors. So that is x equals 1 and x equals negative 3. Those are the two vertical asymptotes. Now, the x-intercepts. Well, that's where the top is equal to 0. And if the top is equal to 0, then each one of these, by the zero factor theorem, must be equal to 0 as well. So that's when x equals negative 1 and when x equals 4. Finally, for the y-intercept, we just take the original. Imagine all of these x's being 0, because that's what a y-intercept is. It's where x is 0. So all of these x's are 0, and we're just left with negative 8 over negative 6. And that will give us, reduced, y equals 4/3. Alright, one last thing on this whole business. We need to plug the x value of the whole into the reduced version of the function. Remember that this function is equal to this function for all values except at the whole. The domain of these two functions is not the same. Think of this as the one that builds the bridge over the whole. So, f of negative 2 is equal to negative 2 plus 1 is negative 1. Negative 2 minus 4 is negative 6. Negative 2 minus 1 is negative 3. And negative 2 plus 3 is 1. So this is going to give me negative 6, positive 6, over negative 3, which is equal to negative 2. So the whole is at negative 2, negative 2. So we take all this information and we graph it. So first let me graph my asymptotes. They are going to be the guides. So my horizontal asymptote occurs at 1. Now this is a soft limit. We can cross the horizontal asymptote, but it's end behavior. So eventually we'll want to trend towards it. The vertical asymptotes, however, are hard limits at x equals 1 and x equals -3. Under no circumstances can we ever cross these values. Now, with those guidelines in place, let's start putting in points. Well, we know that the x-intercepts are at -1, at 4, and our y-intercept is 4/3. So that's a little bit more than 1. And our hole is at -2, -2, so somewhere around there. Now, there are 3 sections to this graph. The middle one is actually pretty well mapped out. We've got 1, 2, 3 points, and these asymptotes are going to guide us. We're going to skirt the asymptote, go through the hole, through the x-intercept, through the y-intercept, and then keep going up. Over here, we can either have the graph be above or below the horizontal asymptote. Because it has an x-intercept, I think we're going to be below. So I'm going to come in like this, and then go out to the horizontal asymptote. And then on the left, because I don't have an x-intercept out here, I'm inclined to believe that our graph is going to reside in this portion of the graph. So it comes in, goes up, and then it shoots up through here, and then it goes out and matches the horizontal asymptote there. So there's all of the work for a rational function.